Then the next slide is about our printed. Once we were done with the design, this is the printed circuit board, and the main features are the traces are designed to be as wide as possible, and this is for preventing short circuit. And another feature is the copper polygons, and also another major feature is the single ground plane. And now I'm going to turn the mic to Boris. He's going to talk about test evaluations.
Before any product can hit the market, it must undergo a process of testing and evaluation. Our three main concerns were: does the circuit behave the way it's supposed to? Does the repeater repeat a signal from an access point to a client computer? And how safe our product is? The first step in verifying the circuit behavior is to check the efficiency. Pretty much from the solar panel or wind power or AC power, the power must go through around 4 diodes, but there's only a 1.4 voltage drop because we use Schottky resistors throughout our design. The second step was evaluating our overcharge protection circuit. As you can see in the graph, when the battery reaches a certain voltage, the gate level on transistor Q4 goes high. That means there's no current going into the battery anymore. We can change that threshold level by simply modifying the value of the potentiometer shown in the picture. The undercharge protection circuit, as you can see here as well, whenever the battery hits a low voltage, say 12 volts in the case of the pink line, the gate voltage goes high again on the transistors, and this prevents battery current from going into the radio board, so the battery doesn't discharge anymore. The blue line, well, actually that's the blue line, my bad. The yellow line, the pink line represents the time when the battery is reconnected to the radio board, when the battery is recharging again, so that we don't want the two lines overlapping, because then we'll have the transistor switching very fast. So we had to add hysteresis. And here we see the performance of our overspin protection. Whenever the voltage of the wind turbine hits around 16 volts or 17 volts, the gate voltage of transistor Q6 goes high, so that actually goes low. That's not the right graph, I'm sorry. And this allows current to go through the dump flow resistors that Omar was talking about before. And now we're going to show you a video of our repeater board, fully operational. We tested it at Mason Parking Lot K.
Right now, here we are at the Mason Pond. This is the group members, and we have our station set up right here. According to the antenna, we're trying to connect to the Mason Performing Art building, and we're going to get, this is where the access point will be. Here's our relay station, and we will attempt to get a connection down K-Lot. Here we are on the other side of the Mason Pond. As you can see over there is our relay station with Omar.
Okay, I'm still connected to the router board. I got a very good signal, and the connection speed is about 39 megabits per second. I'm still able to reach the internet. Let's see, I go ahead and refresh the page here. It refreshes just fine. I'll go to another website here. Go to the Microtech website. And it loads up. So we've got a pretty good connection. We're across the Mason Pond right now.
Same place Alex was connected to internet a few seconds ago. I'm not connected to anything. Windows cannot find any networks. And okay.
The Performing Arts Center building is right there, and our relay station is right here. As you can still see the solar panel from our station. And we're standing here far back in the parking lot K.
That's too much video.
Yeah.
All right, I'm still connected to the router board. Connection speed's about 39 megabits per second, and I'm still able to reach the internet. On the Mason email page yet again. Try to go to the Microtik websites, and it loads up. Go to Gmail, it loads up. You can see we got pretty good connectivity even as far out as we are.
Okay, our very first concern was safety of this equipment. In some cases, we will have AC power running through the lines, so we needed to place warning signs so that people do not touch anything, any live wires, and you know, that could be fatal for them. So we also tested. We also put color-coded wire where we have AC. We use green line for ground wires, white lines for neutrals, and black wire for live lines. And we try to use as many spade connectors as we could throughout our board, so that anyone doing any maintenance to it cannot pull any wire from it unintentionally.
Okay, now we're going to talk about the interior layout of the Linkroamer. As you can see right here, there's a two 12-volt, 12-amp batteries. Right here is the charge controller. Here are the power resistor for the wind turbines. Here's the AC box, the mean well, warning sign, and here's the Microtik board. Now, what we learned from this project